Okay. So I have the charging and charging and discharging. Discharging of capacitor. Okay. Capac capacitors. Okay. And by the way, this is the newly added topic. Okay. And it was added in 2022, I think, right? Where the last time syllabus changes. So it was added that time, right? So so by the way, this topic has a slightly high difficulty level compared to the previous topic of the capacitance. Okay. And mhm. But it's not that much big, smaller topic. Okay, so let's try it. So we have okay. So if we imagine a circuit, let's say I have a battery. Okay, a positive terminal and a negative terminal. Okay, and we have a wire connecting it. Okay, and I have the capacitor with me. The capacitor with me. Okay, right, and I have a resistor. I'm placing a resistor to control the current in the circuit, right? If there isn't any resistor, then it would be very like a heavy current flow through it, and it end up like exploding the circuit, right? So, okay, now, so this is a simple circuit, right? And let's say the battery is of 9 volts, 9 volts, okay? And this is a resistor. This is to limit the current. Okay. And this is the capacitor of the capacitance C, right? And I have the voltmeter with me. Okay. Let's say a voltmeter with me. Okay. Can you guys tell me how long will the capacitance charging? Like in term of voltage, if I say, then how many voltage will should be appear across the voltage till the complete of the charging? Can anybody please tell me? Yes.
What's it?
Like, how long will the capacitor be charging? If let's say I have a battery of 9 volt, okay, the EMF of the 9 volt, and if I place it in the circuit, right? So the capacitor will start charging and the potential difference start developing across the capacitor, right? So till which point or till which potential difference the capacitor will be charging?
Then it's zero.
It start from zero, right? So initially the voltmeter reads zero, right? And to which point it read something that stops the charging process. Yes, any idea?
Oh,
No idea. Okay, so basically, it will be charging till the 9 volt appear. Yeah, come on. Till the 9 volt appear across the capacitor, right? So, and this is a very important concept, right? Capacitor charges only the point where the potential difference or where the EMF of the battery generates across the capacitance, right? That's it. So we say that the charging of the capacitor last till mm, last till the till the voltmeter reads same voltage as of the battery. Okay, is that clear, guys? Yes. This is the first concept, right? Capacitor will keep on charging till the potential difference of 9 volt generated across it, right? And then it will stop. So this is the first concept, right? Now, if we try to look at how or by the way, the resistor is to limit the current in the circuit, right? Known as charging resistor. Charging resistor, right? So this is the concept. Now, if we try to look at how the voltage appear across the capacitor, so it looks like this. It looks like this. V with respect to T, so it will be like that. Okay. And this point is the V naught, the maximum voltage, right? That the capacitor can ever store, right? And it is a exponential process, by the way, right? It does not store at once, okay, or linear. It will store like exponentially. Initially, it will initially the charging will be at a very higher rate, and then it will be at a very slow rate, okay, and then it will be zero, right? I think you guys may notice your electronics devices charging process, like the mobile or laptop or tablet. So initially it charges slowly, right? It charges quickly, and then as the batteries is near to be full, the charging will be the charging is like slow. Okay, so we can say that charging at higher rate initially, okay, and charging at slower rate finally, right? This is the concept, right? And the current will start decaying, okay, in the circuit, because capacitor, we know that the capacitor it stops the DC current or blocks the DC current, right? So the current will be like this, okay? With this be the initial current I naught, okay? T and I, right? This is the main concept. Okay. So these are the simple concept of the charging, right? And initially it charges quickly, and as it is charged or it is partially charged, then the charging process slows down until it is fully charged, right? Now, the process of charging or the process of or the understanding of the charging of the capacitor is not the part of the syllabus, but we have to understand it a bit in order to understand the discharging concept or discharging procedure. So I think that would be enough for us to understand the charging of the capacitor. Now let's do the discharging process, okay, which is a part of syllabus, by the way. Okay, so you should remember, by the way, that capacitor charges till it will have the same voltage as the voltage of the battery, right? This is a point that you should keep in mind. Okay. Now, so if we talk about the discharging process, so okay, I have the discharging process with me. Okay. Now, in the discharging process, let's imagine a circuit first. Okay, I have this circuit. Let me just take this circuit and okay, so this is a circuit. Okay, Mhm. And let's say if I just remove this thing and let me have another resistor. One, two, three. Okay, so okay, so this is okay. Now this is another circuit. Okay, it contains basically two circuits, right? The first one, the top one is the discharging one, and the bottom one is the charging one, right? Now, let me have a switch. Wait, come on. Okay, I have the switch right here. Okay, and this point right here, and this point right here, right? Now, and let's say that this is the switch that I can move it to point A and point B, right? Now, if I put the switch at point A, then it will start charging. Okay. If I take the switch at point B, then it will start discharging, right? And you can do it either manually or you can do it automatically, where the switch will oscillate between A and B. So if the switch oscillate between A and B, if the switch oscillates between A and B, A and B, okay, with a frequency of F, okay. So the current, the current is given by I is equals to. I is equals to CVF, right? So this is the relationship. By the way, they ask you to prove it. So let's try to prove it first. CVF. Okay. Now, to prove this thing, to prove this relationship, we can say that Q is equals to IT, the formula that you guys learned in AS. Okay. And Q is equals to CV, right? The formula that we learned here. Okay. So if I just equate the two things, so I'll get CV is equals to IT, right? And we also know that um, T or F is equals to 1 over T, right? So substituting that in, so I'll get CV is equals to I times 1 over T, right? And then you can make I the subject. So it will be, sorry, this is F, okay? So I is equals to C, V, and F. This is the relationship. Okay. Where C is the capacitance of the capacitor and F is the frequency with which the switch oscillates. Okay. And the rest of the things are the voltage. Okay. So yeah, this is a simple concept, right? If the switch oscillates, okay. This is when the switch oscillates. Okay. But if you just move switch to the other position B, or if you just want to see how the discharging works, so for that, let's try to take this circuit first. Okay, this circuit first, copy and paste. Come on, paste. Okay, paste. Now, so imagine this circuit. Okay, imagine this circuit. Okay, and I am connecting the switch to this point. Come on. Okay, so switch to this point. Okay, so as we connect the switch to the point B, it will start discharging, right? And the discharging part would be like this, opposite to the charging point. Okay, opposite to the charging point, right? So this is the discharging part. While the charging part would be, wait, what would I say? So charging part would be like this. Okay, and the discharging part should be opposite of that, right? So charging part was like that, and discharging is like this. Okay, now, mm, if I place the voltmeter across both of the thing, this one, okay, so this is the voltmeter, right? If I'm considering the previous scenario, right, mm, where we connect the battery of 9 volt, okay, and we are discharging it through the resistor. So basically, the resistor will take the electron's energy out from the resistor, right? So wait, okay. So initially, as the discharging process begins, initially the wait, initially, initially the PD across the battery. Okay. And rather than battery, you can say capacitor. PD across the capacitor. Okay. So initially the PD across the capacitor will be same as same as PD, come on, PD across the resistor. It should be the other way around, by the way. Initially the PD across the resistor will be the same as the PD across the capacitor. Okay. And since the rate of discharging is the same is the same for both the capacitor and resistor, right? So the decay in the voltage will be the same for both, right? The decay or the decrease, basically the decrease in the voltage will be same for both, right? So same for both, right? So this is the concept of discharging. Now, if we plot the graph of the discharging, so the graph will look like this. The same graph will be for capacitor. Wait, let me just copy it, and the shape remains the same. Copy, but paste. Okay. Okay. So, but over here V over T, Q over T, Q is against T, and I against T. Right. So these are the three capacitor, these are the three graph for the discharging. Okay, the voltage follow this path, the charge across the charge on the capacitor follow this, and um the current follow this this path. Okay, now if this sometime ask you to find the capacitance and the resistance, and for that you have to use the initial values. Okay, so every time the initial value is going to be V naught, Q naught, and I naught. Okay, always keep in mind. Okay, always keep in mind, for the initial values only. Okay, for the initial values only. Okay, you can use Q equals to IT. Okay, and Q is equals to CV, where Q naught and V naught will be there. Q naught and I naught will be there. And the third thing is going to be Q V is equals to IR. V naught is equals to I naught R, right? So be very careful. These are the three formula that will be very much useful in this chapter. So and mainly for the starting values, right? Now, for any instantaneous value, instantaneous values, okay, we use this equation: x equals to x naught e power minus t upon tau, okay, or t upon rc, right? This is for the initial values. This is for any instantaneous value, right? Any value, right? And this equation is, by the way, very useful, right? And very important. So over here, x is going to be the initial quantity, okay? X naught is going to be the quantity at time. X naught is going to be the quantity, initial quantity, and x is going to be the instantaneous quantity, okay? And t is a time instant, by the way, okay? And r and c is a time constant, okay? So this is the initial quantity, right? And this is the instantaneous quantity, instantaneous instantaneous quantity mean quantity, like what will be the value of the quantity after some instant of time, right? And this is the time instant, right? And this is the time constant, right? These are the four things that we have in our formula, but we also have to understand the concept of x, okay? So x is going to be, or x is basically representing three quantities, okay? mm, and these are the three quantities, okay? The charge, sorry, come on, charge, okay, current, and voltage, right? This is the concept of, this is a, like, these are the three quantities that are being referred by x, okay? So you can use this equation in any of the term, right? Depending upon the questions or the scenarios or the variables or the values that you have been given with, okay? Now, to understand this thing, you first have to look at the time constant concept, okay? And then we'll be moving on to the new thing, okay? So, come on. Time, okay, okay. Now, so the time constant is basically tell you the rate of discharging of capacitor, right? This is the simple concept of time constant, right? And The formula of the time constant is RC, okay, where this is tau, okay, and R is basically the discharging capacitor, and C is the R is basically the discharging resistor, and C is a capacitance, right? And the unit is going to be as -1, okay, and it's a scalar quantity, right? And there's a fact that you should remember, and that is the capacitor take 5 time constant to discharge completely, okay? So we say that capacitor, come on, 5 time constants to discharge completely, okay? And this is something that you need to remember. So wait, can I? Whoa, 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 whoa. 3.5, 4.5, 4.5. Okay. And what? Why? Okay. Now you just need to remember this. Okay. So instead of time constant, just adding the remember me. Mm, remember me. Okay. Wait. Fine. Come on. No, no, no. Remember me. Okay. So hmm, now we have to prove, or we have to calculate the um equation that show this concept. Okay. So let's imagine a circuit. Let's imagine a circuit. Just bring it right here. Okay, to be visible. Okay, now let's imagine a circuit, discharging circuit. Okay, let me take this one, copy and paste. Okay, let's try to figure out um so the capacitor of capacitance 120 microfarad, okay, is there, um has a voltage PD equals to 9 volt, right? So first thing that you have to find out is the charge stored, okay, across the capacitor in microcoulomb, right? The first thing. Now, the second thing is, so charge is going to be, we have to use CV, okay, and C is 9 volt into. 120 microfarad, right? So that gives me 12 into 9 is how much? Mm, 12 into say 108 microcoulomb. Okay. So this much of charge will be stored. This much of charge will be stored across the capacitor at one initially, right? Now, I have the discharging capacitor, and let me take the value of the discharging capacitor as R is equals to 20 mega ohms. Okay, right? So, or let me take no 0.5 mega ohms. Let's say 0.5 mega ohms. Right. This is the value of the discharging capacitor that is given. Okay. Now, if I want you to find out using this equation, Q is equals to Q naught e power minus t over RC, right? Using this equation, if I ask you to find out the charge, okay, charge at t is equals to wait, or let me just give you this value is smaller than that, so that it is like 0.005. Wait. 0.005 into 108 and 0.05, 5.4. Okay, would be good. 0.05. Okay. Let's say this is the value of the resistor, right? The discharging resistor. Now, I want you to find out the charge at t is equals to what was the time? Okay, at t is equals to 10.8 second. 10.8 second, right? And this is the first time. This is the second time at um 5.4, at 27 seconds. Okay. These are the 2 points where I want you to find out the charge stored on the capacitor, right? Basically, as you close the switch, the charge on the capacitor will start moving through the resistor, and they lost their energy. Okay, and they get stored at their original position. Okay, which is the discharging concept, right? Now, so if we apply this equation and Q is equals to Q naught. Okay, you should remember that this is the maximum charge that is stored on the capacitor. And oh man, shit. Wait. Wait, just give me a second. 20, 6. Okay. And if let me just change the values to 12, 12, and 30. Okay. Okay, fine. So if I use this equation, Q equals to Q naught e power minus T upon RC, right? And for the first time, T1, Q1 will be there. Okay. The initial charge is 0.108 microcoulomb. Okay. I'm not converting it. And e to the power minus T, which is 12 divided by RC, which is going to be R is 0.05, okay, exponent 6, okay, and C is going to be 120 microfarad exponent negative 6, right? So can anybody please find out the charge of Q1? Yes. Anything you're getting? I'm getting the value of 14.16 microcoulomb, right? So out of this much charge, out of this much initial charge, the only this much charge left. Okay. Now, for the second, okay, for the second case, okay, for the second case, if I try q equals to q naught e power minus t over rc, right? And so q2 is equals to q naught, which is 108 microcoulombs, okay? And e to the power minus t, which is 30 divided by 0.05 into 120, okay? Yes, any value. I am getting q2 as 0.727, okay? Microcoulomb, microcoulomb, okay? So you can see that initially when the charge was 108, after 30 seconds it is approximately zero, right? Approximately zero, right? This is the first concept. And but how would we know when the charge will completely be zero or approximately be zero, right? So we wrote in a statement that is the capacitor take the time constant, the capacitor take 5 time constant to discharge, right? So 5 time constant mean you can find out the time constant value, by the way, right? So one time constant is going to be the capacitance, the product of the capacitance and the resistance. So capacitance is 120, okay. Capacitance is 120 microfarad, exponent -6, and resistance is going to be 0.05, 0.05 mega ohms, right? And okay, 0.05 exponent 6, right? So when you figure it, when you find that out, so you'll get 6 seconds as your time constant, okay? Clear? Now, if this is 6 seconds, which mean how much of the time constant is needed for the complete discharge? So we know that we want 5 time constant, right? Time constant mean if we times that by 5, okay? So 5 time constant means for this case it will be 30, right? So if we when we worked out at 30, so you can see that the charge store is even less than 0, less than 1, right? So this is approximately discharged fully, right? Approximately discharged, okay? Right now, so this is the concept of discharging of the capacitor, right? We have to do some more things about the linearization process and the half-life equation, but I'm stopping the class right here. Okay. We'll do tomorrow the linearization concept and one more thing, and then it will be done. Okay, I told you guys that I'm going to be taking a test of the capacitance in the next week. probably on Thursday, maybe, right? On Friday. Let's take the test on Friday. Okay. So it is going to be 14 November 2025 and Friday is your capacitance test. Okay. I think I have posted the recording on the YouTube, but I will check it out. I am going to posting the remaining lectures as well, so don't worry, and I'll provide you with the notes as well. Okay, so that's it. Challenge. Okay, take care, guys. Allah Hafiz.
Obviously.
Allah Hafiz.